conflict and incentive model within that value chain, documenting a series of decisions at maybe a material or product level.
The biggest impact, and it's a bit of a scary one, we might be underestimating certain components of the building. So interiors and MEP are actually two very good examples where we sort of use rules of thumb on how much embodied carbon gets attributed to the building because of these components, but they're very rough and I would say probably very wrong as well. The clients are starting to demand for certain climate budgets and carbon budgets to be met. We start to see the value of materials in a different way. So carbon is just a reflection essentially of how much resources we're using to create something.
Hey Phanos, thanks so much for joining me today. I really appreciate it.
Thank you for inviting me, Jack.
Why don't we just start by you introducing yourself and the work that you do?
Sure. Yeah. Again, thanks for the invitation and really nice to be here and to chat. So my name is Phanos. I'm one of the co-founders of 2050 Materials. 2050 Materials is basically a company that provides real-time climate data to be integrated into existing construction workflows. And through this way, we help construction and architecture companies integrate data and transition to a low-carbon construction industry.
The way that we procure, we manage, we design, we deliver materials is very much at the forefront of our ability to make a bit of a shift in terms of decarbonisation. I guess we could sort of go in so many different directions to start, but maybe if we just sort of start at the top around what is the industry's current approach to materials if you sort of take like a large sort of construction site or a large development, how does the industry typically approach the mammoth task of sort of sourcing materials?
It's a great question, and it's one I've been kind of studying, I guess, through our work the last few years. I would start by saying it's a pretty traditional method. It's very manual, and it relies on many different fragmented systems. And then to add some like spice to it, there's a lot of let's say unofficial happenings and quotes. So there's a lot of work that's happening that's not necessarily going through a very defined system. It's very project specific. It's very manual. It's very fragmented. That's kind of like the initial starting point of what I've seen at least the last few years. And then I would say in terms of kind of the management of both the procurement process, but also anything around specification, it's very often reactive rather than proactive. So it's very much kind of, we do the things that we're used to doing, and then we realize there might be a problem, or we realize we've exceeded a budget, and then we sort of go back and try to fix things or try to find alternatives. So those are the two kind of main things I would say is what we are seeing today.
With the construction industry, getting on top of the flow of materials through the sector is a mammoth task, because there are very few sectors around the world or industries around the world that are as fragmented as the construction industry. I mean, I read that your average project has over 100 different organizations involved across that full end-to-end supply chain. So it's incredibly fragmented, which means that it's very difficult to sort of manage and track and measure the flow of materials between different organizations. I'm interested in, I guess, sort of where that sort of first decision point comes from, in terms of who makes the decision on what specific materials are needed. Because I feel like it's a bit of a sort of can of worms question, because you would imagine that it is always at the client level, client deciding what sort of material. I know the industry, and I'm assuming it's not as simple as that.
I wish there was a single answer to your question, honestly, because it's again one of those things that I would love to map out and connect all of the points in the industry and figure out, this truth. I think in reality it really varies per project. I can start by giving you the theory of how it's supposed to work, I think, and then I'll give some like anecdotal examples of how it's actually working from what we've seen. So the theory is the client has a project, and sometimes they have certain requirements in terms of their budget, their aesthetics, their location, of course, like all of these sort of topics. Sometimes that includes materials. So, for example, if a client knows they want a building in central London that has a glass facade, then that's already something that the client will define. But mostly the requirements by the client or the definitions of what the client comes with is more around the use of the project. So if it's an infrastructure project and it's a highway, it needs to tick certain requirements of functionality, but not necessarily, they don't necessarily define what kind of materials will be used. So then what happens is you have the design side of the industry, which takes the client's requirement and turns it into a design, which includes some level of material definition, which is called specification, at least in the building space. So the architects indicate what kind of materials should be used on the design that they're drawing. So if we pause there, you would say it's mostly the client and the architect, or the client and the designer, I would say, because they handle the top-down demands for what this building or project needs to fulfill, and then they define, okay, how do we actually achieve that?
So theoretically, then the designers will define the specifications, product specifications, like you say, and that will then be passed on to an additional supplier to then source those materials, and it will essentially almost sort of go into market with a bit of a shopping list. Is that right?
Exactly. So in the theory is exactly what you mentioned. So there is the specification list, which is a shopping list, I think is a nice way to put it. And then let's say the contractors and the subcontractors take that shopping list and they go and buy things and they use the design to start building the project. The reality, I would say, is that the shopping list is very much taken as a kind of vague suggestion that is often not seen, at least by the contractors and the rest of the supply chain, as a necessity. And I think there's several cultural reasons for that, which is, designers and architects, for example, they don't really build the buildings, right? They are more theoretical because they do the design. They sometimes don't take into consideration the cost aspect of materials, which is, of course, something that is very contractor specific as well, so very supply chain specific, and depends on the economies of scale. But what does end up happening is there is this initial list, but a lot of the list gets changed or what is being called like value engineered out. And then the definition of value is a flaky one, I would say, as in like it does correlate to monetary value, but it also just depends a little bit on who can source what material from where.
That term value engineering is one I've heard elsewhere, and it's such a funny term for something which is essentially trying to sort of polish the design to try and sort of squeeze out a little bit of extra cost. But I imagine it's sort of as, again, when the design or the sort of the intention gets passed through suppliers, that is when sort of each organization, each touch point with that design then has the opportunity to do a bit of value engineering and maybe sort of try and optimize and cut the edges here and there to save a little bit of money, because otherwise the margins just are obliterated at each and every supply chain level.
Yeah, agreed. I do think though that the way that we define value is important, especially in the context of the climate crisis, because if we go back to the shopping list, let's say scenario, if you make a shopping list and you indicate, the ingredients you need to make a really nice pizza because you're having friends over, and I end up value engineering that out and buy the cheapest frozen pizza, probably your dinner will be a little bit different than what you anticipated, right? So I do think like cost is, of course, a very important topic, but it's not everything that the specification includes when the architects and the designers create it.
I guess one of the challenges with that is the conflicting incentives. The the conflicting incentive model across the different types of organizations and stakeholders within that value chain.
I agree, and I think it goes back to what you initially said, which is there's so many companies involved in a single project and so many stakeholders within the supply chain of a construction project, where we're sort of losing some level of information. So the architect might know what the client has asked for and what is important for that project, but the subcontractor probably doesn't have access to that information by the time it gets to them. So there is this, let's say, lack of a thread that lets the information trickle down to everyone in the industry.
It's almost like that sort of game you'd play as a child, where you'd have to you'd hear something, then you'd pass it on, and
Exactly, yeah.
And then right at the end of the chain, find out that you've been talking about something completely different to what it started as. So I guess we've spoken a little bit about the theoretical side there. So what maybe should happen? Life doesn't work like that. So what does it look like in reality?
Again, I think it does depend on projects, and I don't want to be too cynical. Like, I have seen projects that work really well, especially when the top-down, let's say the clients essentially are really proactive about what they're looking for, and they try to remain involved during the processes. So they try to kind of keep the process as they expect it to be. But I would say on the average project, what happens is there is some information from the client, which is sometimes considered in the early stages of the design, sometimes reflected into the specification document. So there is, I would say, a reflection of the goals of the customer, or maybe the goals of the regulator, if we're talking about climate topics. And then when it goes down the supply chain to the contractors, to the insurance discussions, a lot of these things change during the process. And unfortunately, both because of the timeline difference between the design process and the actual construction, as well as because of the kind of big topic of cost in projects, which is inevitably big because margins are so thin, we sort of revert to the typical processes that we do. So every contractor will eventually go and procure from the supplier that they know and they have maybe good quotes from. The process of construction, again, talking about kind of materials and the climate context, there's a lot of bio-based materials that are being pushed in specification lists right now. And that's great from a climate perspective because they have a lower carbon footprint. There is a mismatch sometimes between the knowledge, not just the procurement of those materials, but also the knowledge of actually building with those materials. So building a concrete building or a steel building is different to building a mass timber building. And the same goes for using, hemp insulation versus rock wool insulation. So there are gaps in the industry that are also, I don't think anyone means to necessarily block climate friendly decisions, but it's just maybe a gap of knowledge, cost reasons. So there are multiple reasons that make these sort of decisions drop off.
Gap that you spoke about, and then also then that sort of gap that we spoke about earlier around almost the theory and the reality. That gap essentially is to be bridged through improved transparency, right? Transparency around the materials that we have access to, our supply chains. Is it a challenge around transparency that you also see here?
There is definitely a challenge around transparency. I think for me, transparency, when I think about transparency, it's a lot about data. So in today's world, the way to be transparent, in my opinion, is to be open with having the data shared with the next stakeholder. And to some extent it is, right? So the specification list by the architect does go out to the next stakeholder. So it does exist somewhere. The problem is that unless you map the different stages of the project to the data points and you track what has been changed or maybe kind of dropped off, transparency in itself at different stages that lives in a silo is not as useful. So I think there's a lot of information. There's already existing transparency from the material manufacturer side, not a lot, but it's increasing. So I think the challenge is really, can we figure out what data has been exchanged on a project and sort of map it on a timeline to understand the actual reasons of why certain decisions maybe did not happen as we initially intended to.
It's a case of sort of almost like sort of documenting the flow, documenting the series of decisions across the project, and decisions at a maybe a material or a product or product level. Is that right? And the idea there is that it can is that is so what does the end result of that look like, or the sort of the output of that? Is it that it produces it unlocks or leads to lower carbon buildings, or an efficiency or a sort of deliverability value proposition? What does that sort of output and that sort of outcome of improved uh, documentation of decisions along that flow look like?
It's both of those, in my opinion. So, from an efficiency standpoint, what happens if you track data across the project while you're still in one of the stages of the project? First of all, you have traceability on what has been decided and why. So if that thing that has been decided goes against one of the core principles or targets of the project, you can sort of say, guys, we need to fix this. And then you maybe go back and say, okay, why was X specification changed, like value engineered out for something else? So there is a component of allowing the industry to be proactive by giving them access to what has happened um, kind of historically, I want to say, sort of like during the earlier stages of the project. So that is actually efficient, because what would end up happening if one of these requirements is actually a requirement is that you would only figure it out at a much later stage, and then you would really go back and you would have a huge impact on everyone's budgets and margins. So there's an efficiency component there. There's a second component of, reducing carbon emissions and creating more sustainable, or I don't really like the word sustainable, like climate neutral, I would say, buildings. So buildings that have a lower impact on the environment, because when you do map this sort of information and data to the workflow of the project, you're able to actually start taking data-driven decisions. And what that means is everyone who is creating, say, a specification or a procurement list or a life cycle assessment of a project can do that not just for reporting purposes, because it's sort of demanded by the typical construction process, but for the purposes of making a better decision, which can lead to lower emissions of the building, but also ideally, higher margins at the end of the day, both because of the return on investment on construction projects that are more climate neutral, but also because you're actually being more efficient in your process of designing and constructing buildings.
What do the enabling factors of this look like? There's clearly a need for better information management at a supply chain, at each and every supply chain level. But what about if you sort of go further down the line to actually the building materials companies? What sort of enabling factors or sort of evolution do you think that they need to go through in order to be able to unlock this really ways of working?
I think on the building manufacturer side, what they need to do is prioritize transparency. And I'm quite hopeful, because that's actually happening at a very rapid pace. So when we talk about environmental and sustainability transparency, there is this quite rapid movement of building product manufacturers generating environmental product declarations, so what's referred to as EPDs in the industry. So these are documents where essentially a manufacturer hires a consultant or a different company to come to their factory and take the relevant measurements of how much energy is being consumed and how many emissions are being created for the manufacturing of a single unit of the product. So let's say one brick. And then they publish this information in, usually it's in a PDF document as well as in some open databases. So that's step number one. It's great. We need to do it. It's starting to happen at scale. The second step is we have all of this data now that's sitting in manufacturer websites and open databases, which in theory allows us to take the second step towards transparency and data-driven decisions. Unfortunately, it's a very manual process, of course. If you look at a bill of materials or a cost plan that has thousands and thousands of materials and products referred to, that would mean we would spend probably a couple of years just looking for the right data point in these PDF documents. So this part of the problem is something that we're trying to fix a lot. So essentially gather a lot of that information into a structured database and offer it in a way that is, I would say, mappable and like classified in ways that everyone relates to it. And then the third step is the actual integration into the process of construction. And there again, there's like very interesting technologies that are starting to enable the ability to map data to all kinds of processes during a construction project. So I think as long as you do have the data in a clean format, as long as the building manufacturers are willing and able to be transparent about their environmental impacts, the other two parts of the equation are relatively solvable.
I want to dive into the first point, if I may, that you made around EPDs, so environmental product declarations. In a world that is increasingly trying to shift towards sort of life cycle assessments, sort of carbon assessments of our buildings, how ready for this this analytical, how ready for these assessments is the building material industry, and what does the maturity look like across the different types of materials, for example, like your sort of concrete and steel? How ready for these types of assessments are we as an industry?
It's a really interesting question. I would say that technologically and resource-wise, we are quite ready across the different sectors of building materials. And what I mean by that is we have the people and we have the software to generate EPDs for, in theory, every single material on Earth. Currently, cost is a bit of a challenge for creating EPDs, so it still costs a lot of money to create a single EPD, which means that if a manufacturer that has 15,000 variations of my product and I need to create an EPD for each, it's a significant cost that I have to go through essentially on a yearly basis. So these EPDs last for 5 years, but there's some level of yearly fees that you need to undergo. So technologically we're ready. However, what's happening now is there's certain categories of building materials that it's easier for them to both justify the cost, but also to generate these sort of EPDs. So structural materials like steel, concrete, timber products, they have a lot of environmental product declarations because their processes of manufacturing, while they might have, for example, several mixes, it's easy for them to create an EPD generator that lets them spit out thousands of EPDs for all of their variations, because essentially the core process in the background in their manufacturing plant is somewhat similar for all of the mixes. There are categories then of architectural materials, so like bricks and cladding and insulation materials, where it's a little bit more challenging, but there is quite a good head start, I would say. So there's a lot of environmental product declarations for those categories as well. And then there are a couple of sectors of building materials that are really lagging in terms of information. So one that's always, brought up in discussion is MEP. So electrical equipment, HVAC, like all of the electrical components that go into a building. And one of the reasons at least, that they lag behind generating EPDs is exactly because there's so many variations, and there's even a lot of customization on a per building level. So if you look at any large scale commercial project in central London, most of the systems are custom made for that project, which means it would eat into their margins, the margins of the manufacturer, to generate an EPD specifically for that project. And then another industry or sector that's also lagging a little bit behind, mostly because it hasn't had as much demand up to now for transparency of their impacts, is the FF&E components, or like the furniture, both outdoor and indoor component. And the reasons are sort of similar. So interiors have not been considered as a huge impact on the environment, although there's maybe that's a whole different discussion, but there's a very interesting research that shows that it's sometimes more relevant, but up to now it hasn't been asked for as much, I would say, by the industry. So these manufacturers haven't had to create EPDs. And then secondly, they have many variations for their products. So that just makes the cost of EPDs quite high.
This sort of inconsistency across the materials marketplace, what sort of impact does this have on our ability to sort of reach that sort of end target outcome of increased transparency around decisions?
I think the biggest impact, and it's a bit of a scary one, I think, is that we might be underestimating certain components of the building. So interiors and MEP are actually two very good examples where we sort of use rules of thumb on how much embodied carbon gets attributed to the building because of these components, but they're very rough and I would say probably very wrong as well. So one of the risks is we are assuming that we are doing an assessment of the building and including all of the materials that are used, but in reality, we're making some pretty rough assumptions and estimations in the background, and that has, impacts in terms of just the climate. Because if our carbon outcome of the building is maybe 1.5 times what we estimated, then that adds up. If you look at the building sector,
it just shows how impossible the challenge of defining or quantifying our scope 3 emissions is. It's
100%.
Yeah, when there's so much difficulty in actually just understanding what goes into some of these products, it's an impossible task.
Totally, and I think something that's really interesting. So I come from a kind of life cycle assessment background in my studies, and it's a very interesting methodology to calculate the environmental impacts of a system, whether that system is a product or a building or anything like that. But the purpose of life cycle assessments was to calculate the environmental impact of, let's say, a product that gets created in a manufacturing plant in order to do it really detailed, identify what we are doing bad and good, and then sort of pick out the hot spots and improve. It works really well if you work in a factory, but buildings are not really made in factories, right? So what happens is the amount of material and the design and the structure and the sourcing location of each of the materials is so immensely different between buildings that we are doing life cycle assessments as a kind of end of the project understanding of what we've done rather than a way to improve and take data-driven decisions. And that's why I strongly feel like life cycle assessments are necessary, but they're necessary in a more live format, if you like, where they happen on an ongoing basis during the project rather than at the end of the project.
So we spoke a little bit about the drivers for organizations wanting to adopt this approach around efficiency, as well as then actually sort of measuring our carbon. I want to speak a little bit about, I guess, almost the sort of the external factors and the external drivers and pressures for actually needing to do this. I mean, just to sort of start off, like a great example is in the water sector at the minute around actually introducing economic incentives at a regulatory level to incentivize the quantification of quantifying carbon, but also then the further reduction of carbon across the design and delivery process. What sort of, I guess, sort of external pressures, whether it's incentivized or whether it's the sort of carrot or whether it's the stick approach, do you see within the space?
I would say there's kind of 4 different incentives I see. So one is the clients that have the kind of biggest and what I would call more fancy projects are starting to demand for certain climate budgets and carbon budgets to be met. So there's a certain incentive which says, if I want to work with this client, I need to be able to track my carbon emissions during the design process, not just to report a number at the end, but actually to achieve a certain carbon budget that is being set to me by the client, and to show the client that I actually have the capabilities to deliver such a project. So there is the first incentive, I would say, a pure attractiveness of you as a stakeholder in the built environment, and whether or not you can work with certain clients that are asking for that. And the side comment there is, these sort of clients, the reason they ask for this information is usually that they've published some sort of ESG target or goal in their own annual reports, and now they need to have that ESG target trickle into the real business, and part of that real business is, of course, the real estate component. So it is something that, is increasing.
Which is a really interesting point, because the misconception around sort of ESG targets is that it's sort of like a moral greenwashing type element, but actually the ability for sort of large multinational companies to meet their ESG targets determine the cost in which they can then take debt out from the private debt marketplace. So it really does actually impact their ability to finance their organization, whether they can meet their ESG targets or not, which is a really interesting sort of evolution of that space. So naturally, it's very reasonable and fair for those requirements to then be passed on to their supply chain and their developers. And it's really interesting the way that you spoke about a carbon budget, because obviously suppliers will be given given a sort of a price that they need to meet, for example, or a time period or some sort of regulatory commitments that they need to align with. But a carbon budget is an interesting one.
Absolutely, and it's something that we see being introduced more and more, and it's very interesting to use the word budget, and I think it's really smart from the client side to use the word budget, because in the industry we're in, when we hear budget, we sort of know that that's what we need to meet, right? Like if we are above the budget, then we sort of lose out basically on what we would make as profit. And I think it's a really interesting approach also because the way that you achieve, or the way that we stay hopefully within a livable planet, and the way that we limit climate change impacts is exactly by limiting the carbon emissions that go into the air. And it actually doesn't matter, where the limitation comes from. So the typical approach is also in climate science is you're saying the global budget of carbon for the next 10 years is X. And then you take that X and you divide it across countries. And then you say, the UK has this much, and the US has this much, and China has this much. And then each country takes that budget and essentially divides it into different industries and sectors. And then they say, the iron and steel industry or the building industry has this much. And then within each industry, of course, each person takes that budget and then splits it down to their own whatever work they're doing. And in the real estate space, if you look at the developer, for example, their core business is putting buildings together. So it would only make sense to take their ESG budget and then divide it on a per building level so that they know they can achieve it. And I really echo what you said. I think ESG changing from nice to have to something that is affecting companies' bottom line is very much what we see happening. And I think it's taking some people, it's shocking some people, but it's definitely, a wave that is not going to stop, I think.
What role do you think the regulator has to play in this?
Really good question. I mean, when I started talking about kind of the 4 types of incentives. So the first one is sort of this client demanding for things. The second is, again, not regulators. So it's sort of the return on investment of the client, just from a pure performance of the building. So there's some research that's starting to show that, buildings that have certain sustainability certifications or that meet certain sustainability standards actually can be rented out for more money. So there's a clear incentive purely that relates again to the bottom line. And then the regulation component, it comes, I think to kind of swipe out the rest of the industry that doesn't necessarily work with the leading clients that are asking for that. I do think that there is always going to be a movement with the best companies and the biggest projects to always do better than what the regulators are asking. But the regulators' role is, to come in and say, okay, we have examples of how this works because of these large projects. Let's now define a framework that everyone has to adhere to. And truth be told, the tail of the market, so all of the small projects, whether it's houses or anything that's not a fancy building in central London, is accounts for a huge amount of the carbon emissions of the built environment. So I do think regulators need to step in and look at the examples that exist and turn them into a framework that they demand from the rest of the industry.
I think the role of the regulator here really needs to be quite mature. Maybe is the right word to describe it. I think the role of the regulator here needs to, I guess, quite mature, which is maybe the right word to use. It's not just often regulators are sort of seen as taking this hardline approach and sort of forcing people into line, but actually I think where for an issue or sort of for a priority as important as carbon assessments and understanding the sort of the carbon footprint of the built environment, like you said, so much of the marketplace is made up of really, really small organizations. The regulator and sort of supporting organizations really need to play a key role in supporting them in actually be able to make that jump, rather than just sort of taking the stick approach and sort of forcing them into line. Because inevitably there'll be a whole load of organizations out there that do not have the resource or the skills or the knowledge, et cetera, to be able to sort of make that shift. So I'm really interested to see over time how the regulator and supporting organizations support those smaller players to sort of make that shift.
I'm very glad you mentioned that, because one of the things I've heard more recently is the concept of green loans is not a new concept, of course, but sort of relating green loans and lower interest rates for projects that have certain sustainability performance criteria that they can actually report back to the banks is a really nice way that the regulator can step in and create a carrot rather than a stick and say, okay, you can actually achieve a better return on your project if you include some sustainability metrics and tracking. And I just want to mention that, because that's often a common misconception, a more sustainable project does not mean a more expensive one. And I think that was a common misconception for many years. And yes, if you want to do the absolute most innovative materials that just got released into the market, it might mean higher costs, but there are there's many available low-hanging fruits that you can do and stay within budget and sometimes build cheaper than what you would. So I just wanted to mention that, because I think some people think that it's a trade-off between cost and sustainability.
Totally agree. And I see this absolutely all the time across the industry. Sustainable developments doesn't mean that you're putting in loads of sort of fancy new materials straight off a research line or a fancy architecture firm. Actually, one of the most impactful ways of improving the carbon footprint of a development or an asset is to design it out. And therefore, if you are designing out elements of that asset, you're saving material, you're saving time, you're saving material. So then it's actually can unlock a huge amount of cost saving as well as then the carbon. So it's such an important point. So I'm really glad you mentioned it. And I guess that sort of almost sort of sticking on that point. So what this sort of evolution of material and decision transparency, what sort of impact do you think this will have on the way that the industry designs and builds as a whole, beyond the sort of the saving of carbon? What sort of impact do you think it will have on the way that we approach the design program?
I think carbon has an interesting side benefit, which is we start to see the value of materials in a different way. So carbon is just a reflection, essentially, of how much resources we're using to create something. And that, we've very much become accustomed to seeing lots of concrete, lots of metal, lots of plastic in our lives without really giving value to that kind of material. So I think in some ways it brings us a little bit in the past. So certain materials are easy to get to and they don't require a lot of resources, and we see a lot of them. And that's maybe how it sort of should be, because it creates a more regenerative system. And some materials will always have their use. So steel will always probably exist in some format or another, but we'll start to value it in a very different way. And I think that maybe if I can also kind of mention another topic. I know we're a little bit short on time to really dive into it, but the concept of circular economy and revalorizing materials that exist in buildings. So essentially extracting materials from an existing building and creating a new building is very much something that, contributes to climate action and contributes to reducing carbon emissions. But it also contributes, I think, to the way that humans see the world and the way that they interact with buildings around them, because everything sort of becomes a resource again. And I think that changes a little bit how we see the world as a whole, instead of this kind of linear process where we just waste a bunch of stuff. We start to see opportunities in materials and in approaches in life. Maybe that's a bit philosophical, but I really think that it does change people's mindset to start thinking towards this direction.
I absolutely agree. I like that. What would you say have been your sort of learnings within this space? And what sort of advice would you give to folks maybe sort of starting off on their journey, and if they are maybe at what advice would you give to sort of folks at large organizations maybe sort of starting off this journey?
So I think the first advice would be take it step by step. I think there's some very easy wins which would already create a lot of improvement in both traceability and transparency and tracking of information that don't require you to overhaul your entire organization. So you can still kind of start with the easy steps. And then the second suggestion, which is more from our experience, what really, really works, it seems to me, is to just find one client that's open to doing things better, more innovatively, more transparent, more digital, and test out how you can do that on a project. That usually, creates, at the very least, marketability for the company, because you show that you can work in a mode of the future. And even more importantly than kind of the marketing aspect of doing this, it actually teaches you as an organization what steps you would need to do to actually achieve a stage where all of your projects are ideally done by tracking information, reducing carbon emissions, giving back to your client what they're asking for, and eventually, building a more sustainable world.
What a beautiful point to finish on. Phanos, thank you so much for your time. I really, really appreciate it. It's been absolutely fascinating.
Yeah, likewise. Thanks again, Jack.